Okay, so in this video, we're being asked to find the equations of the lines tangent to the curve f of x that passes through the point -1, -3. Now, we know that f of x is going to be a quadratic, and we're not told how many tangent lines we have here. So it could be 1, 2, we really don't know how many lines we have here that are going to be tangent to this curve and also passing through the point -1, -3. What I want to do really quick though is just draw a quick picture as to what they're actually looking for. So if you have a quadratic, right, and we'll just say that, okay, this point right here is going to be -1, -3. Essentially what they're looking for, they want to know where these tangent lines are going to be occurring and where they're going to be passing through on this curve. So for example, based on the picture I have here, we could possibly have a tangent line like this one here, okay? So go ahead and put the arrows on. We could also have one that may look something like this here, right? And so that's essentially what they want. They want the equations of these lines. So how do we do that, okay? Because it's not very straightforward. Now, in order to do this, you have to understand what a derivative is. And if you're on this video, you probably know how to take the derivative, but you have to go back to the definition, okay? And if you need a quick refresher on the definition of a derivative and where it comes from, check out my video below on the difference quotient. That would be a great refresher on giving you more insight on the derivative, where it comes from, and what it exactly is. But I can quickly go over it here, and that is the derivative is going to be the instantaneous rate of change at any point on the curve, okay? And as a result, that ends up being the slope of the tangent line at any point on the curve. So when you take the derivative, again, you are finding the instantaneous rate of change at any point on that curve, and it ends up being the slope of the tangent line at any point on that curve, okay? And so what we need to do here is we need to find what f prime is, meaning we're going to have to take the derivative of f of x. So we are essentially going to take the derivative of y in respect to x. So for example, I'm going to say dy dx is equal to, now taking the derivative here, we're going to use the power rule. You get 12x and then plus 5, okay? And so this is the instantaneous rate of change, or in other words, this is going to be the tangent line at any point on that curve. And so think about what's going on here now. What else do we know here? Well, we know that the slope between 2 points is going to be y2 minus y1 all over x2 minus x1, and that will be equal to your slope. Well, look, I have my slope right here, okay? So think about how you can do this problem. Well, think about if you had a point on this curve. I'll just go ahead and put a point here. How could we illustrate that point? Well, we're not given any x or y values on this curve, but we could say this point is going to be x, comma, f of x. Okay, where f of x is actually going to be this whole part right here, right? And then we're given this point right here. Okay, so we actually have 2 points. So in other words, I could say that this point right here is going to be x1, y1, and this point right here is going to be x2, y2. And so now I'm going to plug it into this formula here, and we're going to see what happens, okay? So my y2 is f of x. Well, what is f of x? It's this whole part right here. So I'm going to say here, 12x plus 5, that's my slope, right, is equal to, well, I'm going to have 6x squared plus 5x plus 2, and then minus y1. What's my y1? My y1 is a -3. So that becomes a +3 because of the 2 negatives. So I'm going to go ahead and put +3 here. And then on the denominator, I have x2 minus x1. Well, my x2 is x. And then I'll have my x1, which is going to be -1. But again, the 2 negatives make a positive, so it becomes x plus 1, right? And now from here, you want to solve for x, because when you solve for x, you are going to be getting the x values where these tangent lines are passing through on the curve. And then we can use that to our advantage, and I'll show you how. But we want to solve for the x values here. And again, that is going to give you the x values on the curve where these tangent lines are passing through, okay? So we're going to go ahead and do that, meaning I'm going to have to multiply both sides by x plus 1. So in other words, I'm going to have 12x plus 5 times x plus 1, and then equal to 6x squared plus 5x, and then plus 5, right? Just combining like terms. From here, we have to FOIL this part here. We're going to get 12x squared plus 12x plus 5x, and then plus 5. And what I'm going to do here, I'm going to scroll down. That way I have room to combine like terms, and then I'll go ahead and rewrite the whole problem. So combining like terms here, I get 12x squared plus 17x plus 5 equal to 6x squared plus 5x plus 5. So you can clearly see here that I'm dealing with a quadratic. So how do we solve quadratics? Well, we set them equal to 0, and then we try to factor. If we can't factor, we'll use the quadratic formula, right? So I have to move this term, and this term over to the left-hand side, okay? When I do that, I have to subtract 6x squared. That will give me 6x squared, right? 12x squared minus 6x squared. And then I have to do 17x minus 5x. That will give me plus 12x. So plus 12x. And then I have to do 5 minus 5. That's 0. So this whole thing here is going to be equal to 0 now, okay? And so from here, can you factor? Now this one worked out really nice because we can. We can pull out a greatest common factor and then solve. But let's say you get to this point here and you can't factor. You're going to have to use the quadratic formula. Not a big deal. Plug this into the quadratic formula and solve, all right? This one worked out nice though. I can pull out a greatest common factor. When I do that, I get 6x, pulling out the greatest common factor, and then I get x plus 2, all equal to 0. When I solve, I get 6x equal to 0, and I get x plus 2 equal to 0. Again, taking my factors and solving. That leaves me with x values of x is equal to 0, and then x is equal to negative 2. So again, let's reiterate here what these values mean. These are going to be the x values on the curve where these tangent lines are passing through. So in other words, one of these tangent lines is going to be passing through the curve where the x value is going to be 0. And then another tangent line is passing through the curve when the x value is negative 2. Okay? So we're pretty much done at this point. There's not much left we have to do, but you need to go back to the slope that we found by taking the derivative. So the slope that we found was f prime, again, the derivative of f of x, and this was equal to 12x plus 5. So at this point here, I want to get the actual slope of that tangent line. And we're going to do that by using these x values that we found. And so all you have to do is plug in 0 into x and get your slope. Same thing with negative 2. Plug it into x and get your slope. So I'm going to say here the following. Slope number 1, because I'm going to have 2 of them, right? I'm going to have 2 lines here. So slope number 1 is going to be 12 times 0 plus 5. That's going to be equal to 5. So there's one of them, okay? Slope number 2, what's that going to be? Well, that's going to be 12 times a negative 2 plus 5, right? So this ends up being negative 19, okay? So now put it into slope-intercept form, solve for b, and you will have the equations of those tangent lines, okay? So for example, let's scroll down. We know that slope-intercept form is going to be y equals mx plus b, okay? So doing the first one, what am I plugging into y? What am I plugging into x? Well, remember the point that it's passing through. At the very beginning, it said that these tangent lines were passing through the point negative 1, comma, negative 3. So those are going to be the values that we plug into x and y. So for example, I'm going to say here negative 3 is equal to my slope, we'll use this one first, 5, times my x value, negative 1, plus b. So we get negative 3 equal to negative 5 plus b. When I solve for b, I have to add that 5 over, and I end up getting b is equal to positive 2. So b is equal to positive 2. There's one equation, okay? So one equation is going to be y is equal to 5x, my slope, and then plus 2. Okay, there's one of them. All right. Now we have to get the other one. So to get the other one, again, I'm going to plug in negative 19 now into my slope. So I'm going to say here, negative 3 equal to negative 19. My x value is negative 1, and then plus b. Okay, so solving for b, this ends up being positive 19. So I have to subtract over 19. So I have to do negative 3 minus 19. That gives me negative 22. So b is equal to negative 22. And then finally, putting it all together, we get y is equal to negative 19x and then minus 22. Okay, and that's it. So you just found the equations of the tangent lines passing through the point negative 1, negative 3, and they will in fact be tangent to the curve, in our case here, that quadratic. Okay, so you can go ahead and graph this out, you can test it out, but those are going to be the equations that you end up getting. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe, that way you get more math videos in the future, and I'll see you in the next one.